Picture an ordinary Tuesday. Coffee's brewing, the morning commute is grinding along, and the sky looks exactly as it always has. Then, without warning, the stars overhead start to ripple and stretch, as if the sky itself were made of liquid. What you're seeing is the approach of the most extreme object in the universe, a black hole. And in the next few minutes, we're going to take Earth on a one-way journey straight into it, step by step, to find out exactly what would happen to our planet, our atmosphere, and the very fabric of time itself. Welcome back to the channel, where we turn the universe's biggest what-ifs into real science. This thought experiment isn't just for fun. It reveals some of the strangest and most beautiful physics we know. Stick around to the end, because what an outside observer would see is even weirder than what happens to Earth itself. Let's begin the descent. Here's the first surprise. The answer completely depends on which black hole Earth falls into. They are not all the same. A stellar mass black hole, formed from a collapsed star, perhaps 10 times the mass of our Sun, would be compact and savagely violent. A supermassive black hole, like the one at the center of our galaxy weighing over 4 million suns, is so vast that its boundary stretches wider than the orbit of Mercury. And this matters enormously, because of one key idea: tidal forces. A black hole pulls harder on the near side of an object than the far side. The smaller and denser the black hole, the more brutal that difference becomes. So Earth's fate hinges entirely on the size of its executioner. Let's take the violent option first. So what happens if Earth meets a small, stellar mass black hole? Brace yourself. It's not pretty. Long before Earth ever reached the black hole, it would be destroyed by gravity alone. Because a stellar mass black hole is so compact, the gravitational pull on the near side of our planet would be vastly stronger than on the far side. That difference would stretch Earth out, first into an egg shape, then into an impossibly long strand of matter. Scientists have a wonderfully unscientific name for this process: spaghettification. The planet would be torn apart, its rock and water and metal ripped into a stream of debris spiraling around the black hole. As that material falls inward, friction heats it to millions of degrees, and it begins to glow ferociously, forming a brilliant superheated ring called an accretion disk. In a grim irony, the matter that was once our oceans and mountains would blaze brighter than a star in its final moments. There would be no surviving this. But there's another scenario entirely, and it's far stranger. Now let's drop Earth into a supermassive giant instead. And here, something genuinely counterintuitive happens. Because a supermassive black hole is so enormous, its tidal forces near the boundary are surprisingly gentle. The difference in gravity across Earth would be mild, so our planet could, in theory, cross the point of no return, the event horizon, completely intact. No stretching, no tearing, at least not yet. And here's the truly mind-bending part. There would be no signpost, no flash, no barrier. The event horizon isn't a physical surface. It's simply the boundary beyond which escape becomes impossible, because you would need to travel faster than light to get back out. People on Earth's surface might cross it without feeling a single thing. The sky would look distorted, the stars smeared into a ring, but life could continue for a short while, utterly unaware that the entire planet had just sealed its fate. From that moment, every possible path forward leads to one place: the center. Once inside the event horizon, the rules change in a way that's almost impossible to picture. Here, the warping of space-time becomes so extreme that moving toward the center, the singularity, is no longer a choice. It becomes as inevitable as moving forward in time. You cannot steer away from it any more than you can steer away from tomorrow. As Earth fell deeper, even a supermassive black hole's tidal forces would eventually grow overwhelming, and spaghettification would finally claim the planet on its way down. At the very center lies the singularity, a point where, according to our current theories, density becomes infinite, and the known laws of physics break down completely. We genuinely don't know what happens there. It's one of the greatest unsolved problems in all of science, sitting at the crossroads of gravity and quantum mechanics. Earth, and everything that ever lived on it, would meet an end that physics cannot yet describe. Now for the twist I promised. Imagine you stayed behind on a distant spaceship, watching Earth fall in. You would not see it vanish quickly. Because of a phenomenon called gravitational time dilation, time itself runs slower in stronger gravity. So as Earth approached the event horizon, From your distant viewpoint, it would appear to slow down, more and more, until it seemed to freeze right at the edge, hovering there forever. At the same time, the light leaving Earth would be stretched to longer and longer wavelengths, shifting from visible light to red, then to infrared, until it faded from view entirely. To the outside universe, Earth would never quite finish falling in. It would simply dim and fade, frozen at the threshold for all eternity. Yet from Earth's own perspective, the crossing would happen in moments. Two completely different truths, both real, separated only by where you happen to be standing. That is the strange, beautiful logic of a black hole. Let's ground all of this. Black holes are real, observed objects. We've directly imaged them and detected the gravitational waves of them colliding. The physics of tidal forces, time dilation, and event horizons is well tested and forms the backbone of Einstein's general relativity. What remains unknown is the singularity itself, the heart of the black hole, where our best theories simply stop working. So while we can describe Earth's journey with remarkable confidence almost all the way down, the final chapter is still being written by physicists today. So, what if Earth entered a black hole? If it were a small, stellar mass one, our planet would be shredded into a glowing stream of matter long before it arrived. If it were a supermassive giant, Earth could slip past the point of no return intact and unaware, only to be drawn inexorably toward a center that physics cannot yet explain. And to anyone watching from afar, Earth would appear to freeze and fade at the edge, frozen in time forever. It's a sobering reminder that the universe runs on rules far stranger than our everyday experience, and that the most ordinary planet can lead us to the deepest mysteries of all. If this journey bent your mind the way a black hole bends light, do me a quick favor. Hit that like button, because it genuinely helps the channel reach more curious explorers like you. Share it with a friend who'd find this fascinating, and if you're not subscribed yet, tap that button and ring the bell so you never miss where we travel next. Until then, keep looking up. The universe has far stranger journeys waiting for us.